Welcome back to our Scala class, and today we will talk about the enumerations. So it's a way of providing a certain fixed number of values when you don't necessarily care about the actual numbers, but you just want a limited set of values. Again, could be maybe days of the week, months of the year, maybe fingers, which we'll take a look, maybe something specific. Again, it's a way of, structuring your code. So I won't spend too much time because in Scala 3 they are introducing a slightly different syntax. So you don't have to use this, but it might be useful to know the idea, at least, the philosophical idea behind this, which might be more important. So I'll be using some of the guides from Bildung. I'll post a link here, as there's also some other ones on Geeks and also the standard library. So I will make a new, we have day 16 today, right? So I'll do enums, Scala class, object, so day 16 enumerations. So basically, it will be a class which we are going to be extending, right? Add, extend, of course, not a trait. There's also a way of doing it with sealed traits, but we won't cover that today. So extends app, right? Let's have some fun. Let's have some fun with fingers, right? Finger enumerations. So enumerations, and I can't type, right? I'm gonna of course compile it as usual, just to make sure everything works, our builds is not failing. Looks like we are in good shape. So, in fact, I will also do maybe something simpler first. Let's do something from the Scala book, actually, from official book. I'll do an object. So object color extends, right, enumeration. You see there it is, right? So, again, and I can do these things like this. So, val red equals value. So this is the most basic way of doing it, right? Value, and actually it should be nothing, actually. Should be nothing. Let's see. Val green equals value again. I think that has to be like without this. Yeah, okay, yeah, that's correct. Because, and of course, we should learn to spell. And then val blue equals value. So basically, we're saying this particular color has these constants in red, green, blue, and at this moment we just don't care. And again, so we are just basically building specifications. The color should have red, green, blue, nothing else. So of course I can do now print line. I can do basically color red. You see, I have nice values, right? Of course. Again, just green for now, right? Let's see what happens. Really simple idea, right? But quite powerful again. So it prints green, right? In fact, what's interesting is these are assigned values actually. So for example, starting with, I believe, 0 or 1. They're starting 1. So let's check this. Print color, let's say blue ID. You see ID, and this will give me 3, I believe. This will print a numeric value, which we generally do not care too much, right? When using enums, right? So again, it's a way of assigning some constants. Basically, you say, okay, red, right? We want to use these three particular items, and we don't really particularly care what they actually are, right? But we just want to fix, right? So it's actually so it is 0 based. So let's do one more. Control D. Actually, it's 0 based, so red would be 0, right? Red, right? And I'm purposely changing the order around, so it should be 0 here, right? Yeah, it is 0. So it starts at 0, right? You can change these things, right? You can, in fact, change, and if you decide that you want some specific value here, right, you can actually do it, right? You can say maybe you want an RGB, like maybe some hexadecimal, color scale. You can add it here, for example, right? So I could actually do, I believe I can do it even here. I could do, what's the red, green, blue? I could do maybe, I'll do a string, maybe, and I'll do 255, maybe 255, 0, 0. Okay, maybe something like this. Of course, maybe I would want to have a sequence, a tuple here, maybe. Of course, maybe I would want to store a tuple here, right? So let's see how it works with other ones, right? So this is just a string, right? I could do this, right? So red, green, blue. So this should probably be 0, 25, right? again, and of course I might want to change this, right? I might need something else. Again, assuming these are for maybe some web-based application, maybe you need some, or maybe I don't know, some graphics application, you need these values hard-coded, of course. Again, maybe you want this. So it's a possibility. It's a possibility, and let's see what happens. Did anything change? I think you need to do values here. Let's check. Yeah. Yes. So see now when I print green, so ID stays, but green actually gives me the actual value. So in fact, well, I can also do things like this. So I can do print line. So color 0, right? Will give me 255. This is the string. It should give me a string, right? Right. So this will give me a string. I believe it will work. Yeah. So I get back the string, right? So I could store my green. Of course, if I needed this, my green would be, of course, color green, right? This should be a string in this case, right? Well, it says color value, but we'll see. Actually, well, we assign it when we to string. Let's do it to string, right? We'll do it to string, for example, if I need a string, right? If I need a string, right? I'll cast it, right? And I'll cast string because, well, I know, of course, that I'm storing strings here, right? Again, but the way it is, idea is that you are limiting yourself. Yes, you are basically putting a limit to what you can do, right? You don't want the extra colors. You just want these 3 colors, right? So you choose these 3. Basically, use them as a collection of constants, basically, right? So it's quite nice for, well, avoiding some basic mistakes, basically, on putting basically sort of limits to your, well, to your application, basically. So of course, if I do print line, my green, right, and I can print it out. Yeah, and of course I get this result here, right? Whichever the string it was, so it was a string, right? Of course, I could have stored some other things as well. So this generic value, right, is used for storing. There is a shorter way of doing it, right? And I'll show you. Maybe I have another example. Let me put this is from the book. This is nice. More examples. I'll put the fingers here, right? So more examples. More examples here. So, and there's also, of course, Alvin is also with us as usual. Where's my friend Alvin? Not here. That's seal tates. We don't want to use that right now, although it's technically slightly better, but oh yes, here's Alvin as well, right? So we can use that as well, right? Top, bottom, right? So also this. Also some examples. Well, yeah, and also new Scala 3 has a different syntax, right? So that's, I'll mention that as well, so we can get this. Where is it? That's our examples, right? This actually gives you example. You can use that. That might help you with your assignment, of course. Some more assignment might help with example, right? And finally, Scala 3. Yeah, so this is the upcoming, well, it's actually already live. You see, there's slightly different syntax as far as you do enum, actually, right? A full, but the idea is exactly the same, basically. So this is has different syntax, right? Has, okay. So let's move one more example since we have time. We are doing pretty good, right? So we'll do fingers. And notice again, so this object, why is it an object? So because it's a singleton, notice objects, so singleton meaning we only have one color object, right? Again, so this is, so when you type object color, right, it's basically, it's like a class, and then you create an object, a single object out of this class, basically. Think of it like this, right? So when I write an application, I say, okay, this is only one application, it's called day 16 enumeration, right? And of course, then I do all my regular class stuff inside, right? So when I type object, again, it is a singleton. So this fancy name, singleton, it actually means it's basically a single object, right? You can't create more than one based on this color, right? Because, well, you don't need more than one, right? You just have color, you use it everywhere in your application, right? So quite nice. A tuple of three values here, right? Right, so that might be a possibility. And let's see our fingers. Let's see our fingers. Is there anything interesting here? Well, so we create a little shortcut, so it might be slightly shorter, right? So might be easier, right? Something like this, right? And we can do all of them at once. You see, thumb, index, middle, ring, little, right? So we can do some fingers, right? So let's do looping, right? We can loop through, and we can loop through all of the values. Right, so we can do basically for color, right? Color. I just came up with name in color values, right? And I can just basically print line color, right? So looping, right? And it will print all the color, right? Yeah, it printed all the colors, right? All the colors. And right, printing all the colors, right? So, and similarly, we can print the, of course, we can do, I wonder if we can do all the IDs. Well, I believe, could we print also a color ID? I wonder, color ID? Yes, we can. Yes, we can. So we can get the ID as well, right? I'll do ID, right? So color ID, right? The string, of course, if I want, I could cast something else. So I get the value out, I can cast something on, of course, right? Right, so 0, 1, 2, right? Again, these are all, well, in this case it's string, right? So I'm printing it out like this. Okay, so let's do fingers. Let's do fingers. Same idea, right? How about the fingers? Right? Same idea. For finger, again, simple loop, right? In fingers values, right? My little pinky, right? So my fingers, I'll do it with S strings, right? My finger number, finger, right? Of course, S. Let's see how I do it. S finger, right? How do I do it? Oh yeah, and then finger ID, right? And I can type value. Oh, sorry, finger is small capital, right? Finger, yes, correct. Is a finger, right? Okay. Oh, okay, something again, so maybe slightly nicer, right? So let's see. It's same, exactly same idea, same type of right. And of course, yes, you can actually change these values. Again, these IDs also can be changed, but generally, you know, basically, you know, you don't really need them reversed, basically, right? You just need the values, right? You can print all the fingers, right? So what else? So there's a nice example here. Like you can see, is rude. Okay, shortest I'll do a is rude, right? So, right, is rude, right? We'll make a little function here. Def is rude, right? And in comes a finger, right? You know, some finger, right? I'll just so you know it's right. In comes a finger, right? And let's see if that's correct. And out comes boolean, right? Bool, right? And equals false. What's wrong? Oh, why didn't it pick up on this? Let's see. It should have picked up. Let's check. Finger. It should have picked up. What did I do wrong here? Some finger. Did I need to import it? Import. Yes. Import fingers. Right. Or did I make it? Fingers. Oh, sorry. Right. So the idea here is, right, that I can check, right? I can check a particular. So here, what's the idea of this? Is so I can so all fingers have a specific can be have same you know super basically same type of value basically, right? So this value again is a generic designation, but here we say okay, here the type finger. Notice if not multiple but just finger, right? So we use that to check, right, some finger, or maybe we want to check we'll do is root. Of course, this means it will be Boolean, right? We need Boolean here, right? Boolean, right? I can't type. Why can't I type today? So Boolean, right? Come on, right? Like this, right? Yeah, okay, much better, right? False, no, function works, but maybe we are root. So what we'll do is some finger, not equal, some finger, not equal to what? Well, fingers middle, right? We don't want that one, right? And now we are good, right? Now we are good, right? As long as it's not a middle finger, right? Well, no, is root is equal to, right? Is root being root, of course, logically, right? Is root is middle finger, right? So that's being root. Okay. So that will give us a nice answer, right? So if I give it myself, so you have a collection of fingers, okay, that's maybe slightly scary, but yes, so I can check, of course, is root, right? And print line is root, of course. I'll do fingers on, let's say, ring, of course, right? And I'll do Control D middle. Again, the idea is that this could be used as a collection, right? Right, of signs, maybe. Again, this is probably getting a little, so this will be false, right? And this will be true. This is root indeed. So this is a root indeed. So you can use this as a collection, right? You can have a sequence of fingers, right? Yes, so maybe some sign language, right? I don't know, right? So maybe getting a little silly, but yes, you could have an array of fingers. Yes, okay, but of course colors would be nicer, right? So, but your task, right? So if you got this idea, right? So your task is your daily task. Your task is to create an enum of, well, days of the week, since you already made them days of the week, right? Days of the week, right? An enumeration of days of the week. And again, you could, well, again, you could create a method to check if it's now you can check if it is, again, a weekday, right? Yeah, or it's a weekend. Again, yes, and again, same idea. You can see, right? Again, return, is it a, and create a function, create an outside method now to check if it is weekend. So very similar. So similar logic to what we did in the last lecture with pattern matching, right? Matching. So here the difference is that we are using enums specific, very specific, right? So using specific enums, right? Right. So to limit our choices, basically, right? So okay, I hope you got the idea behind these enums, right? Enumeration. Again, this is common in many languages, right? And again, so Scala actually again, since we can know how to use extends, we basically extend this class and we gain this ability to create our own basically constants, right? Again, so on the again, so this little trick here is so we can actually, well, we can pass along a generic finger basically, right? Otherwise, we can't really do, if you want to do this as colors, you probably want to do colors and then do a color type also, right? That might be an idea. Okay, so that's enough about enumerations, and then our next lecture will be on packaging or how to do namespaces in Scala. Okay, thank you.